Hello everyone. Today I'm going to explain you about virtualization. So what is virtualization? Virtualization in cloud computing is defined as the creation of a virtual version of a server or a desktop or a storage device or an operating system or network resources. It is essentially a technique or method that allows the sharing of a single physical instance of a resource or that of an application among multiple organizations or customers. The basis of this technology is the ability of a computer program or a combination of software and hardware to emulate an executing environment separate from the one that hosts such program. See, for example, we can run Windows OS on top of a virtual machine, which itself is running on Linux OS. So, the virtualization provides a great opportunity to build elastically scalable systems that can provision additional capability with minimum cost. The virtualization technologies have gained renewed interest recently due to the confluence of several phenomena, which are increased performance and computing capacity. So the performance of the machine is increased and underutilized of hardware and software resources, and it uses very less space. Let us see what are the characteristics of a virtualized environment. So first is increased security. Virtualization increases the host ability to control the execution of a guest program in a transparent manner, which helps open up a new possibilities to allow the delivery of a secure and controlled execution environment. All the operations of the guest programs are generally performed against the virtual machine, which then translates and applies them to the host programs. So next is sharing. Sharing is a key feature of virtualization, as through this process one can create a separate computing environment within the same host. This allows them to reduce the number of active servers and minimize power consumption. Aggregation. While virtualization allows the sharing of a physical resource among several guests, it also makes it possible to perform the opposite, that is aggregation. This functionality is implemented with cluster management software, which harnesses the physical resource of a homogeneous group of machines and represents them as a single resource. Emulation. The execution of a guest program or cone within an environment that is controlled by the virtualization layer. Also, a completely different environment with respect to the host can be emulated, thus allowing the execution of guest program requiring certain characteristics despite them not being present in the physical host. So next is machine reference model. So this is the machine reference model. So let us see about it. At the base layer, the model for the hardware is declared or manifested on terms of an architecture, that is instruction set architecture. It defines the instruction for the processor, register, memory and interrupt management, or we can say it as an interface between software and hardware, and it is mandatory for the operating system or developers of application who directly manages core hardware. Next is application binary interface. It covers facts such as low data type cell and cell conventions, and it also defines a format for many programs. Mainly system calls are defined at this level. Next is application programming interface. It is represented by the highest level of abstraction. This API interfaces applications, helps to libraries and the core OS. For an action needs to be performed in the application level, API, ABI and the two which are responsible to make it done. Mainly CPU runs on two privilege levels. Those are user mode and kernel mode. In user mode, what happens means memory access is restricted up to some limit, whereas access to peripherals is denied, which means memory is access to certain limit. We can use only some memory. And in kernel mode, CPU has instructions which manage memory and how to be accessed, and it also has instructions which enable access of the peripheral like disk and network cards. From one running program to another running program, CPU switches automatically. The first mode, that is user mode, can be made within privileged and non-privileged instructions. These instructions, which can be used with interrupting with another task, are known as non-privileged instructions. They are also called so because shared resources are not accessed. Hardware virtualization. Hardware virtualization, it is referred to as when the virtual machine software or virtual machine manager is directly installed on the hardware system. It is known as hardware virtualization. The main job of hypervisor is to control and monitoring the processor, memory and other hardware resources. After virtualization of hardware system, we can install different operating system on it and run different applications on those OS. What is the use of hardware virtualization is it is mainly done for the server platforms because controlling virtual machines is much easier than controlling a physical server. So there are three types of hardware virtualization: full virtualization, emulation virtualization or partial virtualization, and last is para virtualization. Full virtualization. In full virtualization, there is no need for any modification to run any application. In addition, the hardware architecture completely simulates, which benefits the guest software. There is an environment quite similar to an operating system in the server. It means that we don't need to do any modification to run any applications because the environment in the full virtualization is completely similar to what we are doing in the host machine. So with the help of full virtualization, the administrators allow running of virtual environment change to its physical counterpart. And also with the help of full virtualization, the administrator can combine the new and the existing system for something efficient, so it should be compatible with the newer system. So next is emulation virtualization. In this, the hardware simulates by the virtual machine and it is independent. Here what happens means the guest operating system does not require any other modification. In this virtualizations, computer hardware as architectural support builds and manages a fully virtualized VM. Para-virtualization. In para-virtualization, the hardware does not simulate and the guest software runs its isolated system. It is not necessary to simulate the hardware, but it utilizes an API which modifies the guest operating system. Other virtualization techniques. So let us see some other virtualization techniques which are programming language level virtualization, application level virtualization, which means in this kind of virtualization, it allows a user to have remote access to an application from a server. All the personal information and other characteristics of the application are stored in the server, but it can still run on a local workstation through the internet. See, for example, a user that required to run two different versions of the same software. The technologies that uses application virtualization are called hosted applications and packaged applications. So storage virtualization. This virtualization is essentially an expensive set of servers that are managed through a virtual storage system. The servers are not aware as to where the data is being stored. Instead, they have a worker be like aloofness and systematic task. Next is network virtualization. In this type of virtualization, it is the ability to run multiple virtual networks that each have separate control and data plan. They coexist together on top of a single physical network. Desktop virtualization. This type of virtualization allows the user OS to be stored on servers in the data center remotely. The user can access the desktop virtually from anywhere by using a different machine. Application server virtualization. In this type of virtualization, the computer hardware from the operating system and allows the virtual machine to be treated as a file. It gives the user the ability to adjust their hardware to the present workload. Pros and cons of virtualization. So what are the advantages of virtualization in cloud computing? The first advantage is that utilization of hardware efficiently. With the help of virtualization, hardware is efficiently used by user as well as cloud service provider. In this, the need of physical hardware system for the user is decreases and this results in less cost. Next is availability increase with virtualization. It is one of the main benefit of virtualization as it provides advanced features which allows virtual instance to be available all the times. And next is disaster recovery is efficient and easy. With the help of virtualization, data recovery, backup, duplication becomes very easy. Quick and easy step. In traditional methods, setting a physical system and servers are very time consuming. But in virtualization, firstly we purchase them in traditional methods, what we do is we first purchase them in bulk. After that, wait for the shipment. When shipment is done, then wait for setting up, and after that again spend time in installing required software, etc., which will consume very time. But with the help of virtualization, the entire process is done in very less time, which results in productive setup. Then next is cloud migration becomes easy, and virtualization also saves energy. With the advantages of virtualization, we have some disadvantages in virtualization, which are performance degradation, inefficiency and degraded user experience, security holes and new threats. Performance is definitely one of the major concerns in using virtualization technology, and inefficiency and degraded user experience. Sometimes virtualization can lead to inefficient use of the host, and there are some security holes and new threats in the virtualization. So thank you. This was all about virtualization. Thank you.